Hi, my name is Sadman Binzaman. This is EL6303, assignment 9, question 1. Zt equals n1t cosine wct plus theta minus n2t sine wct plus theta, where theta is from 0 to 2 pi, and n1t and n2t are wide sense stationary, and n1t, n2t, and theta are all independent. First, we need to know what wide sense stationary means. So when a stochastic process is labeled wide sense stationary, that means the mean of the stochastic process is constant. So the expected value of some x of t, function x of t, would equal c, some constant. Since n1t and n2t are wide sense stationary, we know the expected value of each of those is a constant. So for our purposes, the expected value of n1t is going to be n1, and the expected value of n2t equals n2. So part A asks us to find the expected value of z of t. So the expected value of z of t is going to be the expected value of what z of t is defined as, which is expected value of n1t cosine wct plus theta minus n2t sine wct plus theta. We can use some quick, we could do a few quick manipulations. We know that we could separate our big expected value into two separate expected values, which would be the expected value of n1t cosine wct plus theta minus the expected value of n2t sine wct plus theta. Again, we can separate it some more. We can isolate the n1t's and n2t's, so the expected value of n1t times the expected value of cosine wct plus theta minus the expected value of n2t times the expected value of sine wct plus theta. Again, since n1t and n2t are wide sense stationary, we know that those two are going to be constants, and we'll label them n1 and n2 respectively. So over here we have n1 times the expected value of cosine wct plus theta minus n2 times the expected value of sine wct plus theta. So we have our n1 and n2 taken care of. Now for the expected value of the cosine and the sine function, we know that our cosine is going to range from 0 to 2 pi. That was what u was defined as. The integral from 0 to 2 pi of cosine wct plus theta divided by d theta, and that's going to be divided by the average value of the function requires us to divide the integral by the interval, which was from 0 to 2 pi, so 2 pi minus 0, and same thing on this side. And we'll have n1 times 1 over 2 pi times the integral from 0 to 2 pi of cosine wct plus theta d theta minus n2, 1 over 2 pi, integral from 0 to 2 pi sine wct plus theta d theta. I have quick sketches of what the graph of cosine and sine looks like, ranging from 0 to 2 pi. We know that from that interval they both equal 0, so we can ignore that. So basically we're going to have n1 times 1 over 2 pi times 0 minus n2 times 1 over 2 pi over 0, which will eventually equal 0 minus 0, which equals 0. Part B of the question asks us to find Rz of t1, t2, and asks us if z of t is wide sense stationary. So a quick note, the autocorrelation rt1, t2 of x of t is the expected value of the product x of t1 times x of t2. So basically Rz of t1 times t2 is going to be the expected value of zt1 times zt2. So we know what basically zt1 is going to be n1t1 cosine wct1 plus theta minus n2t1 sine wct1 plus theta, and z2 is going to be the same thing. Instead, we're going to substitute t2 in place of t. So Rz t1 times t2 is going to be the expected value of the product of these two. And then we can expand that by distribution, and we'll have the expected value of n1 t1 cosine wct1 plus theta times n1 t2 cosine wct2 plus theta, and you can work out the rest by yourself. But a few quick things, we can manipulate like this how we manipulated part A, where we can extract the expected values of the n1s and n2 terms, whether it's n1 t1, n1 t2, doesn't matter. And since we know that we could still go into this problem knowing that n1t and n2t are WSS. We know that their expected values is going to be a constant. So we know that the expected value of n1 t1, or expected value of n1 t2, expected value of n2 t1, or expected value of n2 t2 is going to be some constant, n1 or n2. So RZ of t1 times t2 is going to equal n1 times the expected value of cosine WCT1 plus theta times n1 times the expected value of cosine WCT2 plus theta. And I did not fill out the rest because this is only supposed to serve as a step. So you could obviously do the rest the same way we did the first line. And quick note, the expected value of n1t times the expected value of n1t is the same thing as expected value of n1 t squared, which equals n1 squared, which equals rn1. So we can rewrite rz t1 t2 equals rn1 tau times the expected value of cosine wct1 plus theta times cosine wct2 plus theta minus n1 n2 expected value of cosine wct1 plus theta times sine wct2 plus theta minus n1 times n2 expected value of sine wct1 plus theta plus cosine wct2 plus theta plus rn2 tau rn2 tau times the expected value of sine wct1 plus theta times sine wct2 plus theta. I actually got stuck over here. I didn't know how to continue, but my guess would be that our ZT would not be a wide sense stationary, but I'm not entirely sure on that. Part C of the question asks us to find RZ of 0, assuming that Z of t is wide sense stationary. So if Z of t is wide sense stationary, then RZ tau should equal 1/2 times Rn1 tau minus Rn2 tau cosine WC tau. So we would substitute 0 in place of tau because we're interested in RZ of 0. So RZ of 0 would equal 1/2 Rn10 minus Rn20 cosine WC0. So the cosine of something multiplied with 0 would equal 1, so we could disregard that. So we're basically dealing with RZ0 equals 1/2 Rn10 minus Rn20. And we also need to know that Rn tau is the same thing as n squared tau, which equals the expected value of n squared tau. So now we could substitute, we can make our little substitution here, and then we know that RZ0 equals 1/2 times the expected value, well, sorry, so RZ of 0 would equal 1/2 times the expected value of n1 squared tau minus n2 squared tau. Thank you.